The broadcast is now starting. All attendees are in listen-only mode.
Hi, and welcome to our next ICTM webinar. We are very excited to have Denise Brown here presenting about counting collections, and she's going to get started in a few minutes. But before we get started, just as a reminder, these webinars that we're doing in the next couple of months are helping us to gear up for NCTM Regional Conference that's coming at the end of November, beginning of December. And as fun as it is to have these webinars and to be able to learn kind of, on your own time, it's also a really powerful experience to have a chance to learn in person and connect with peers and colleagues in that way. So we would really encourage you to take advantage of early bird registration, which you can do until the beginning of November. I think you have until November 3rd to register for NCTM Regional, so we can see you there as well. But that being said, I do want to focus on our webinar for today, and we have Denise Brown. She's on the ICTM board. She's the Director of Early Childhood to Grade 4. We're lucky to have her presenting on a topic that is specifically for our pre-K through 3rd grade teachers. We don't often get to hear something that is specifically for those teachers of math. And it's going to help us think about ways to develop early numeracy and promote mathematical thinking. I'm Annie Forrest, and I'm also on the ICTM Board of Directors. I moderate our webinars, and the way that the questions will work during this webinar, on the side you'll see a spot that you can enter questions. If you enter questions, they come directly to me, and I will be sort of curating those questions and sharing them with Denise at the end of the webinar, or maybe at places that are appropriate during her talk. But other participants don't see those questions, so you can feel free to ask anonymously, or I guess somewhat anonymously, because they come to me, and I'm the only one that sees those. All right, so with that, I'm going to go ahead and turn over the screen to Denise so that she can share her knowledge with us. I don't know if that worked.
I don't see anything.
Okay, let me try one more time. All right, maybe because I'm on my... I'll try. There we go.
Okay, there we go. Okay. Well, good afternoon. As you can see, as Annie introduced, ICTM is near and dear to me, so I wanted to give a little bit of a plug at the beginning here for ICTM. These webinars have been, I know, a very great way for us to connect as mathematics educators in Illinois, and I really welcome you to this webinar this afternoon. I'm going to talk to you about counting collections and using these collections to build number sense. And I put pre-K 5 because actually I'm a 5th grade classroom teacher, and I also use counting collections within my own classroom. So I will share a little bit about that this afternoon. My name again is Denise Brown. I teach 5th grade at Carruthers School in Murfreesboro. I've been a teacher leader for a long-running math grant that finished its last year, and been a math coach within my building and a Noyce master teacher. And that's a younger picture of me. So on a school day, I'm a pretty typical teacher. My off days, I like to get out, and then this is a picture of a fossil hunting event at Tower Rock, a great place to go. This afternoon, though, I want to share with you about counting collections for young children. And what I'm going to be sharing with you is based on these two books, cognitively guided instruction books. The one on the right is the second Children's Mathematics, is the second edition of the cognitively guided instruction book, known as the Blue Book fondly by many of us. And it came out of University of Wisconsin in Madison, Thomas Carpenter, Elizabeth Fenema, and Megan Franke, and others, as you see. Young children's mathematics takes the same kinds of ideas and uses them in a younger setting than the original work. Now, so CGI is short for cognitively guided instruction, and I wanted to tell a little bit about what that is as we get going. What's extremely important about CGI is that your work with children is based on their thinking, that their thinking is valued, encouraged, and strategically developed by the teacher. So the teacher's role is one of facilitator. The students are at the center of the instruction in all ways with CGI, and your instruction is changed based on their responses. So, and with the counting collections, student thinking is the center of everything. That's where you start. With a CGI approach, the teacher assesses the student thinking, and this can be done in very informal ways, but formative assessment, formal and informal, but formative assessment is really crucial to this approach. Knowing where your children are and what they're doing and how they're thinking about things is just a necessity. And then the teachers respond to that thinking. So today I want to spend some time on counting collections. And counting collections are when we use groups of objects for students to count, and they develop number sense and counting skills and mathematical reasoning through this process. As you can see, there's a few pictures of some collections down there. Anything can be used for this that you consider safe and that you consider that you think your students would enjoy counting. We'll talk a little bit about how they can be organized, but you can see there that on the right there's some cups of centimeter cubes. Teachers sometimes like to organize their collections in different ways. Here's another in the middle. There's a picture of some loom bands that are arranged in Ziploc bags, and then of course like toy cars could be stored anywhere. But the objects that you use should be interesting to the students. So there's different kinds of collections for different purposes. The collections that you find, this is just something I found in my desk drawer, a group of erasers. Anything really can be counted. And here, like the objects that I've picked, can be patterned. And sometimes you might want a collection that can be patterned in this way, and other times you may not, depending upon your purpose. So some of the counting collections that I have here it can be anything. So for older students, you might want to use collections that are packages of things like the pencils. Obviously in young grades, you're not going to count by 36s, but you might find packages of 2s or 3s of something that would work for the younger students. And then, of course, by 3rd grade, there are many things that are sold in packages that could be counted and grouped and really lead to students developing the multiplicative ideas that they need for the rest of their mathematics. Some other ideas, there's counters here in the middle that they're kind of like, they're sorry pieces. I ordered those from Amazon, and they've been a very useful counting tool as well. I like them because they're pretty safe, they're indestructible, they don't take up a lot of space. So as you think about different ideas for your counting collections, I would recommend that you try to pick a group of objects that are pretty small so that it's easy to store. Having a lot of counting collections will really make the activity probably work better for you too. Here I also have used pom-poms as a counting collection. And then there's a picture here of artwork, student artwork. There's no reason you cannot use things around your building as well to count. It's just the idea is to find things that your students will really connect with and that they can count in a meaningful way. So what collections do you think you could create? And I'd like you to think about that a little bit. What objects do you think you have around that you might be able to use as a counting collection? And if you have any ideas, we can take a couple of minutes to share those.
Yeah, so if you're participating and you want to enter that in the questions area, that would be a spot where you could share some ideas.
Now, one of the best collections I have is a button collection, and I'll talk a little bit more about why that is a little bit later. But one of the first steps really is trying to figure out what you might be able to count and plan for that. It doesn't have to be anything fancy. You don't have to buy things.
You want me to share a few of the ideas that have come up?
Sure, sure. Oh, yes, I don't see those. Yeah.
Yeah. Cups.
Yeah.
Pencils.
Mm-hmm.
Chairs in the classroom.
Mm-hmm.
Borrow groups of items from art or music.
Oh, yes, yes.
Somebody said 2-color chips, flat marbles that I get from the dollar store so they don't roll.
Mm-hmm. Right.
I was going to add personally, I've collected those twist-off tops to pouches, like those applesauce pouches, because my kids eat a lot of those, and I just collect them for that.
Right. Yeah, so the possibilities are really pretty endless. It's just about management, really. What you can tolerate, what's safe, what you think your students would enjoy counting. And I just love this activity because kids just really love to count, too. And so it works really well. So let's talk a little bit about why we should count collections. The big thing is, the most important thing is this is a very concrete way for students to acquire the early counting skills and for you to assess them. And here I have a picture of some of the buttons from my collection. Students really love to count things like this because they're fascinated by them, not just for counting, but just looking at them. And so they stay very, very engaged in the activity. But these are the big three things, is that with early counters, there's three things that they really have to master. And this mastery does not come in one order. It comes like some students might get this, the verbal counting sequence. That is the counting and the number words in the order first in their counts. 1, 2, 3, 4, 5, and so on. And if you're a teacher of young children, you know that you see this happen all the time, I'm sure. But this verbal counting sequence is a way the student knows what comes next in their count. And that's one aspect of it. Students who can count, get the number sequence correct are not necessarily counting unless they can do the other things along with the other two features that I'm going to talk about. They have to have all three and mastered all three in order to really be competent and fluent at counting. So that verbal counting sequence is very important. And I have found that some students, I had a student years ago who was a 5th grade student, and she was having a lot of trouble with her mathematics. I could not figure out where the hole was in her knowledge. And eventually I asked her to count backwards from 50 and discovered that she actually didn't have the counting sequence for the 40s. I don't know why, but I assessed her a couple of times and I found that it was really true. And this was really hampering her with her multiplication, learning her multiplication in 5th grade, and just she had some holes there. So sometimes we think that students have this, and maybe this student had it and passed that up into her 50s.
Mrs. Hanson, please tell extension 3002.
And but this student didn't have that, and it was a real problem for her. Another one that early students have to have is one-to-one correspondence. They have to know that each object is worth 1 and that they should count it. They can't pass over it. And so young children who do not have this skill when they count will often just look at a string of things and count and use their words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and maybe there's 20 things there. And they think that they're done when they run out of their number words, but they haven't counted each object one-to-one. And again, I know early educators all see this very often. The interesting thing to me was learning that students didn't get one of these before the other. And then the last one is knowing that the last object you counted represents the value of the set, so the cardinal principle. And so for students in the early counters need to master all 3 of these aspects of counting in order to be fluent. Now, some of the things that you can do to start your counting collections, create enough collections for pairs of students. So the recommendation in the Young Children's Mathematics book is to have pairs of students work together in this activity. That makes it a very good activity in your classroom, of course, for many reasons, because students learn how to communicate. They work together and they learn from each other. And that's also another really important aspect of CGI, is that students are expected to learn from each other. And so pairing them up is a really good idea. I know in some classrooms that's easier at certain times of the year than others, or you might have classrooms where that's harder one year than another year. But hopefully, if you can get those students working together, it's going to make a difference. You're really going to see students grow more quickly when you can accomplish that. Collecting a variety of objects, and again, I have some other examples here of like great looking paper clips and bottle caps and just anything. Go ahead and collect all those things. And then for early childhood especially, you should vary the number in the collection based on where you're at in your year. So with kindergartners, you don't necessarily want to start out with, 150 objects for them to count, but manage the collection at a place where you know they can achieve some mastery or achieve some fluency pretty quickly. So the recommendation is to start in kindergarten with sets of 25 and then go on up to 150. Now, I've seen many students in CGI classrooms and in kindergarten CGI classrooms who can count beyond 150. So these are definitely just recommendations. Many students, you may have students in kindergarten who are able to count much larger sets, and you should definitely go for that. But typically then, that's kind of the typical range. Then for first graders, 50 to 200 objects is a good amount of things to have for them. In second and third grades, 150 up to 300. And then fourth and fifth grades, 1,000 to 5,000. Now, I know most of you are probably in that K3 range, but it's nice to see too how this can keep going. And I want to make the point that I found that counting collections are valuable well into fifth grade. They might even be into sixth grade. I don't have experience with that, but I've found that students still need to count and desire to count objects. And as our numbers, as the way we use numbers changes, fifth graders, we can count objects maybe in a decimal way or with fractions. So the kinds of numbers that we're looking at change through the years, and students don't necessarily generalize that knowledge that we think that they might. Like if they can count to 500, well, they should be able to count to 800, or they should be able to count to, if they can count to 1,000, they should be able to count to 2,000. That's not always true for everyone. So this opportunity to count larger collections, I think, is extremely important. So this is a picture of my classroom from last year, and students who are counting things, and as you can see, they're quite engaged. Now, it's not the same as what might happen in a kindergarten classroom, although some of the aspects are the same, because I see in the boat there disorganized set of masses. I see the other students who are very organized. You'll see some of those kinds of things no matter what age student you're counting with, and it can provide a lot of information for you as a teacher as to what to work with. So the other thing that you can also do as students become more fluent in, say, science, have more science skills, there might be data sets or population counts, things that you could do maybe in even 3rd grade, that if you collect the whole class's information, so your set of what you're counting can be all kinds of things. And I'd encourage you to look even in the science realm for things that would make appropriate sets for your kids to count that might connect to those subject areas. Now, some of the things you need to think about with the counting collections, how will you group your students? And there's a lot of, again, this is going to be based on your goals. You might group your students sometimes based on social emotional goals, but then you also might group them based on you think one student will help another student gain some kind of counting skill. I often look for students who think the same and group them together, at least initially, so that they reinforce each other. If their strategy is valid, working with someone sometimes who, especially at the beginning, when you're maybe not as confident in your abilities, if you're working with someone who thinks in a more similar way to yourself, you can achieve a lot of growth that really lasts, and then later you can expose them to thinking that's more diverse or different, so that you increase the flexibility. But especially with struggling students, I find that if they can work with someone who thinks more like them, that they learn these skills more quickly. And again, what size count is appropriate? You know, you can always make adjustments if you make a mistake in the classroom and you give a small set of objects to a group or a large set. You can always quickly make those adjustments, but it does make it, if you can get that right the first time, it does help. So think about what size of the count that you want them to do. How often will we count? There's several different strategies for using the counting collections in the classroom. You could count, some teachers like to count every week. Some start out the school year, and in the young children's mathematics, they suggest that you spend the first couple of weeks of the year counting as that initial back to school activity, and then they might do it monthly. So you would, you know, that's something to think about though, but it's one of those stations or activities that you can really build into your day. Sometimes how often we will count might depend upon what your curricular goal is too. For example, if you're trying to encourage 3rd graders to count by 3s or count by 4s because you're starting to think about multiplication, you might have a period of time where you really want to intensify the activity, and then you might back off on it later. I always like to have a lot of different goals in any of the lessons that I teach, even in mathematics, so I think the social goals are important too. Are you trying to, what kind of communication skills are you trying to develop in a student? Are you trying to help someone gain some confidence? This is a perfect activity to encourage those things too. And of course, what are the mathematical goals? So you might be wanting students to, young children, you might have some that you need to work on one-to-one correspondence, or you need to work on the cardinal principle. Of course, those would be your goals. But your goals later on might be things like counting by 2s or grouping by 10s or counting by 5s. Or maybe you want them to use the set to explore some operations or some comparisons. You can use counting collections to develop the ideas of how much is more and how much is less by comparing sets from one group to another, or even asking the students to sort their set in such a way and then asking them those questions. So thinking about your goal before you go in really is helpful. And this last one is on this page is also very, very important. How will I observe and record the student thinking? So that formative, because this activity, at least initially, is so formative, and it's ongoing formative assessment, you want to keep track of where they're at, and then that way your students won't get bored with the activity and they will be continuing to grow and it will run well for you. Now, a typical lesson with counting collections would start out like this, and there's a website from the Downey Unified School District, which I did not get a chance to put into my slideshow, and maybe Annie can help share that out later, or we can look at it. But they have a lot of resources for counting collections lessons at all the different grade levels. But the typical lesson is like this. The students will get their collections and they'll count them. The teacher goes around and asks the guiding questions based on your goals, based on what you know about your students. You look for strategies to share during a debrief session at the end. So you might have a student who just discovered that it's easier to count their collection of 100 because they group them in tens. And then rather than telling the students how to group in tens, you wait for them to do that, and then they can share that during the debrief. And that kind of learning, when you have that opportunity, it really, the students learn more from each other sometimes than they do from us. You would record student work. So this is a great activity for evaluation time or running records, or if you have standards-based, it's an activity that you could get a lot of information from without having to do separate time for gathering some of that data. And so then after that part, you clean up, and then you can get the whole class together and share the counting strategies. With the younger children, sometimes kindergartners at the beginning of the year, they're not going to say maybe be as verbal yet, but you can always look at things too. So you can always have a gallery walk or have a student model what they did and try to get the class to talk about it, or you can narrate or share as well. But sharing those students' strategies at the end helps the kids see some different things, and you can name the strategies if you want to, but that class debrief at the end, that closing section, is also useful. Now, during the lesson, there's some things to watch for, and I promise there's some pictures coming up soon on here and some examples of what counting can look like. Excuse me, I just need a bit of a break there. During the lesson, be open to ways students group objects. Initially, at least the first part, you don't want to really say a whole lot about what they're doing. You want them to see what they're doing. So some students, even though you've been working on bundling by 10 and you're sure that they should do that, or bundling by 5, when you give them a counting collection, they may not group the objects the way that you think that or expect. But when you see those things, definitely ask how they counted. So questions without much judgment will help you gather information about their thinking. And that's one of the best questions that you can ask to a student after they've counted a collection is, how did you count it? And then watch and listen carefully to how they do it. It's as much about what they say as what they do. So watching what they do is going to give you a lot more information. Look for counting strategies that move students thinking forward. So you obviously don't want kindergartners and first graders always counting one by one, Eventually, you would like to have them counting maybe by 5s or 10s, or using some strategy that will be more sophisticated. So you definitely want to look for those things, and encourage kids to use them once they reach that place. And that's also that sort of thing you can share during the debrief, which might move some of the other students forward. And bringing attention to the new strategies as they naturally develop in your classroom will be better than when we provide them for them. So the CGI approach is that these things are naturally going to happen. Let them happen and then really run with it. But if we bring it up, if we give the students strategies before they've figured that out, that's where a lot of math confusion starts in my assessment in early grades, is we're giving them too many things too early that they don't understand. So that's why it's important to wait for that natural development to occur in your classroom. Once 1 or 2 of your students have it, the rest of them are going to get it shortly after. If they finish early, they can always count another collection. And if you have students, the wonderful activity, you can tell I really do like counting collections, but differentiation is quite easy when you're doing this activity, because if you have students who are ahead of the other students, they're more advanced, you can give them a larger collection or ask them to join their collection with someone else, or even ask them, can you make 3 equal piles with your collection? They may not be able to do that. They may have 1 or 2 left over. Even young children they can talk about those ideas, and you can give them those opportunities through this activity that you can't in other kinds of lessons. And then take notes on student work and share with your colleagues. One of the most fun things to do is to compare what your colleagues have found when they did the same activity. Now, questioning is a critical element as well. Cognitively guided instruction implies that you're going to be doing some questioning based on what the students are thinking. So that questioning is a discussion of student thinking. Good questions make students think very deeply. And they start asking each other questions too, once you model this. And it's really great to see kindergartners asking you questions like, what's after 101 or 110? And they don't have the word yet for it. And they're talking to each other, figuring it out. And so those questions really make them think about those things. The questions provoke students to extend their thinking. Another aspect sometimes of mathematics education in our country, I think especially, is that students don't expect to think about the work. The expectation is that I get done and I solve the problem, but questions provoke students to that more advanced thinking, which young children can do. And they are amazing kids. Amazing. I'm sure all of you who have teach young children have seen that. The questions develop the student curiosity. So through this kind of activity, students end up being more inquiry-based just because of that, because of the questions and the fact that things are varied. Great questions keep them engaged, and the questioning makes the task rigorous. And finally, when good questions allow students to develop connections and apply the knowledge. Now this is actually, I did make it in here. This particular website has a lot of activities, lessons, organized by grade level. It's from California. They have CGI lessons, but they also have counting collection ideas and a lot of resources. They have some, there's a great page on there for questioning and some suggested questions that you could use. So if you're serious about using this strategy in your classroom, I really recommend that you go to this website and take a look at it, because it's very well done. So that's Downey Unified School District, and they're in California, dusdnet.cgi. Now, during your counting, as you're watching and observing, I have some slides now that show typical ways that students what they might do with their collection. I like the button collection because it is heterogeneous and not homogeneous. The reason that I like that aspect, and I would encourage you to look for collections that are not all homogeneous, is because it's easier to question about a heterogeneous collection than it is in a homogeneous one. So for example, with buttons, I can have follow-up questions like, can you sort them in 2 piles for a reason? And then they have to analyze that, and they're noticing attributes, and you're doing a lot of more advanced mathematical thinking by asking those questions and having the opportunity. If everything is just the same, it's harder to ask that question. And then they can, of course, sort this again a different way. Or you could ask them, a more advanced student, well, I noticed that there's holes in those buttons. How many are there? And then they might figure out that they're counting by 4s and 2s. And you're doing it in a pretty easy way for you as a teacher. Now, this particular student just got their bag of buttons, and they probably opened them up and dumped them out. They didn't organize them, and this is going to be very typical, of course, for a lot of young children, but it's actually, I see it also in older grades sometimes too. Students who just simply don't see any need to organize. Now, the reason that you watch the students and you think about it is because when I first saw students doing this, I thought, oh my goodness, there's no way this person can count these buttons accurately like this. Well, that's true a lot of the time, maybe most of the time, but not all of the time. I've seen many students who can very accurately count this collection with what looks like no organization, and do it a couple of times, because when they do it once, I'm a little skeptical, so I'll ask them to do it again, because they may not have a starting point. They may not use the same one. But that information helps you as a teacher know what step to take with them, and to help maybe encourage them to organize in a certain way. So this is another typical way that young children will organize their collection. They will put their collection into a circular pattern. And again, this actually has the same kinds of difficulties for the students that the last one did. They don't know where they started or stopped. And also, I've noticed too that students will recount, and so in a collection like this, if they get up to, say, 15 and they don't know what's after 15, they'll go like backtrack and go 12, 13, 14, 15, 12, 13, 14, and like go over and over again. But the circular pattern, they don't always know where they started or ended, but it does show some organization. So that gives you some information about what they're thinking about. I have some questions down here, like what problem might the student have counting this collection, and what question could you ask? So as you are teaching and watching the kids, definitely be thinking about anticipatory, thinking about what you expect that they might do too. Now, some students are incredibly organized. And you will see that, and this is another thing that helps you understand more about your students and how to guide them mathematically. So I have seen a lot of students who spend all of their time trying to organize and sort before they count. And that can be valuable, but sometimes it can get in the way of our thinking if we're too much like that. But yes, sometimes, and some students will group by 10s or 5s or 7s. Actually, my 5th grade class, when we counted this big jar of centimeter cubes, they wanted to count it by groups of 144. And so watching, which was a curious choice, and we talked about that too, you know, at the time, but watching how they do that is pretty important. Now, your follow-up questions, they guide the development of your student or your students' thinking, and it leads to your students developing their mathematical thinking. In this kind of activity, your role is a facilitator to allow the students to do the work, make the mistakes, and figure out the solutions. And they will grow they'll grow quickly, actually. So good questions lead to student growth. Now, some of the suggestions that I have for extending their thinking, and I've shared some of these already. And these, again, are some ideas or some pictures of what students might do. Young students, sorting is a big, is important. And it wasn't until I started having students going into kindergarten and first grade classrooms and watching the sorting happening did I, as an upper grades teacher, realize how important that activity was, because it forced them to observe and notice attributes. And obviously in higher mathematics, that's in science, it's a very important ability. And so those kinds of questions to extend their thinking. And so, of course, if a student, the student on the left top had some reason to sort their buttons into those groups, you ask them to explain that, and you can also ask them for some other just whatever based on what they've done. You can ask them questions, which group has more, how many groups of what do you have, you know, any kinds of questions that lead to where you are. Now, a challenge for the younger ones, they can sort one way, but can they sort a different way? So another follow-up to that is, can you do it again in a different way? And that really gets them thinking. Another question that really gets young children thinking is sorting just into two groups with a collection that is such as these buttons, because they want to naturally put them into many smaller groups, looking for just one attribute to use to say this one either has this or that, is a challenge for them. What attribute do they choose? And that, again, you can talk about that, and it's going to help make your students more observant of quantity, of mathematical ideas, and just of observations. You can also have students, you can have them walk around and share with each other how they sorted things or what they did with the activity. And with that, I think I'm about to the end of my part of this. Hopefully we have some questions and some more discussion.
Yes, we do have lots of questions.
Oh my, okay. Great.
The first question, though, somebody just was kind of hoping that you could repeat that. At the very beginning, you listed those three kind of stages that kids have to have all three of them.
Right.
That part.
So you have the verbal counting sequence and the cardinal principle and one-to-one correspondence. Now, do you want me to briefly explain? Well, the verbal counting sequence is just 1, 2, 3, 4, 5, 6. The cardinal principle is that the last number that I counted is the value of the group or the set. And then the one-to-one correspondence is that when I see one and I count it, like they typically, to show that, students will touch an object and say 1, 2, 3, 4, 5. You know that they're counting one at a time.
Great, yeah, thank you. And then another one, somebody just had kind of a comment, but they said, you know, when they notice kids like to count like 28, 29, 2010, 2011.
Yeah. Right, yes. And what I ask them a question when they do that. So let's say they get to, we might have the discussion of, you have 20 and 10 more. And then what would we call that? And so, yeah, that does happen. And the counting, using the counting collections can really help with that. When I hear that, I try to listen carefully to see, is it that they're seeing groups of 10 and not knowing what to do, or do they not know the counting sequence well enough to know what to say next? So the issue can be a couple of different things.
Yeah. You kind of mentioned this about like kids that will maybe do like skip counting, or but one person was just wondering like, when should skip counting start, or does this, this obviously probably helps with that, but like what?
Right.
More about that.
Yeah, I would think I wouldn't want to start it before the student is ready to see it, because it's really important that they count one at a time until they're ready not to count one at a time. So what I will typically see is if a student is ready to do the skip counting, they're starting to group their collection into 10s or 5s on their own, and they'll even say, well, I didn't have to, I know that there's 100 here because I made 10, and sometimes they make like 10 groups or rows and say, that's how I did it. But I would say typically that's going to be maybe the end of 2nd grade, 3rd grade before they're really, most of them are ready to think about that. Sometimes you can say, well, I'd like you to count like someone, and they can practice that. But if they're not really strong in their counting skills, they may not really be realizing that they're counting by 2s if they don't have those other 3 aspects down, or all of 3 aspects down.
Yeah, that's kind of interesting. Like, do you also, like, if you're skip counting, you might know how to count by 2s, like 2, 4, 6, 8. So that's like a verbal counting sequence by 2s. But then how to apply that to your, it's not one-to-one correspondence, but kind of like every 2.
Kind of is, right, because they may not see each group of 2 as actually 2. It might be to them 1. I said, well, yeah, and it is confusing, but I've seen that. I've been working with this with my 5th graders in intervention time with skip counting, and I've been noticing the same thing, that not all of them see, like when we're counting by 4s, that one group of 4 is worth 4 and that 2 groups of 4 is worth 8. They're almost thinking like it's 2.
Sure, yeah.
Yeah.
Does estimation ever play a role in this for you?
Oh, yeah, sometimes I say, yeah, I do. It depends on, again, that's the mathematical goals. So it won't be the first question that I ask to young children, because before they really know one-to-one or value like that, asking that question only tells you maybe what's the highest number they know or something. But with 1st and 2nd and 3rd graders, and yeah, we often estimate. In fact, the reason we counted 5,000 centimeter cubes in my room was because I had a big jar and I had students who thought there were 300 in it, and there was actually about 4,700 or 5,000 cubes. So yes, I think that estimation it can definitely be a good part of it. This is part of, yeah, that's part that builds the number sense in them seeing, oh yeah, this is a set that might have 10,000, or because I'm finding that older students don't generalize those larger place values the way that we think they might. So I think it's important to do that with the younger students.
We had a question about, do you ever have students record their strategy, like on paper, technology, or whatever, to?
Right. And that's, yes. And if you look on that DUSD website, they have a lot of models of that, worksheets that students can use. And yes, you definitely can have them model their strategies and their counting. I would caution about doing it too soon, because unless they understand what they're writing down, I'm not sure that it's useful until they know. So for example, if you have a kindergartner that doesn't really know how to write down the number 12 or know number 12, that recording that work is not necessarily good for them until they've gotten the basics of the counting part of it. But once they do, yes, they can definitely record their strategies and document their work.
Yeah. And so you talked a lot about, observing and like even recording what the students are thinking, like as a teacher recording their thinking.
Right.
Do you have any like favorite templates or favorite ways to record that helps you to, kind of collect that information as data?
Yeah, I do. I'm very, I like to do things as simply as possible. So I usually have just a class grid that's blank, and then I'll write on it what I'm looking for, and I might have symbols, like I might have a check for students who get it, a minus for students who don't, or a star for students who have it like more than get it, or some symbol to myself, so that, because I don't personally like to write down a lot of things during class, handwritten notes, but I like to have it documented in that way. So for me, the checklist, a grid works really well.
Do you have favorite go-to questions that you use? I mean, I think probably as a teacher, the more you do this, the better you get at asking those questions, but you kind of talked about how important those questions are. Right. So do you have some favorite questions that people can use?
Well, I mean, for counting collections, how did you count your collection is actually my favorite, because it's so, my favorite questions are very open-ended, because I get the most information from my students out of those questions. How did you do it? Why did you do it? What's a different way you could do it? What do you think about, the person next to them? Those kinds of questions, the open-ended ones that are not very specific, are my favorite. And then once I figure out where to go with it, then the questions get more specific.
Right. I mean, it sounds like those type of questions give you more information than like, what did you get for the answer?
Yes.
So like right or wrong, it doesn't really matter. It's like how.
Right. Right. In fact, I really don't ask that question very often. I might ask, how does your count compare with someone else's, like if they're not getting an accurate one, or how could we be sure about your count? That kind of question, I think, is also very helpful.
And you kind of mentioned too, like when you do this type of questioning, the kids become more just inquiry based in general. Yeah. So have you seen this, like, because many elementary teachers teach multiple subjects, so do you feel like counting collections help with other content areas too?
Oh, I absolutely do, because that observation is crucial, the noticing of details. I'm seeing, and I don't know if it's a cultural thing, maybe it is, but it just seems like students maybe aren't noticing things as much, or maybe we don't have time to let them notice things. And that kind of thinking applies to every discipline. It's just a very basic, important thing, a thinking skill. So yeah, I see a lot of classrooms who use these kinds of strategies and these kinds of activities. The culture within the classroom becomes much more learning and inquiry based naturally, because the kids can't wait to count or get to the collection or talk to each other about what they're doing and how it's different or the same. Yeah.
Do you ever like intentionally choose objects that correlate to something that you might be doing in science, for example?
Oh, yeah. Definitely. Yeah, and again, that's going to be based on what your curriculum is. I'm trying to think, I'm looking around because I know that I've done this and I'm trying to come up with an idea. Like, I know we've counted things like how many, when we were looking at multiplication, this isn't quite the same thing, Annie, but we worked on a problem of how many keys are on all the keyboards in our school. So that was, based on the higher numbers, but yeah, well, I'll think about that. Maybe I'll come back to a specific science one.
Yeah, I was just even thinking, you can go for a nature walk and collect leaves.
Oh, yeah,
and bring these back to the classroom, and and then one question just came in too, and then this might be our last question, but when is it that students start putting things into piles? Does this just happen naturally at a certain age? For example, I tend to put pennies in 5s and 10s to make it easier.
Yeah, that's a good question. It's later than you might think. They might do, I typically see younger students first they'll count it out, and they might, like after they get to 10, then they might separate it. And then as they get older, they might start to think about, oh, I could do 10 and then 10 and then 10, which is a little different, but actually mathematically or what developmentally, that's quite a bit different. And I don't see them really doing that till probably 2nd and 3rd grade most of the time. There's some 1st graders who do it, not so many kindergartners at all.
Interesting. Well, this was very interesting. I'm an instructional coach coaching K-8 teachers, and this is but I wish I would have known about this when I taught middle school math. I could totally see 6th graders doing this as well. So I really appreciate you sharing.
And they still need the number sense development up to 10,000 millions. You know, how do they understand these unless we give them opportunities to experience numbers, large numbers or small?
Well, I just love this activity, and everyone that participated today will get a follow-up email that has the recording with it, and people that couldn't attend also get that recording. So I hope people will share this with their colleagues too, because I think it just really honors students as thinkers in the classroom, and I think that's really nice too.
Yes.
So, all right. Well, thank you, Denise. I am going to try to share my screen again here and just wrap us up. So hopefully, are you seeing my screen now?
Yes.
Okay, perfect. So there is going to be a brief after webinar survey that will pop up for people that attended. We would really appreciate it. It goes quick, but if you could do that, that really helps us get some feedback on what worked for you and what you would like in the future. Also, if you attended live, you get CPDU credit now if you would like that, if you're an Illinois educator and you need CPDU credit. So in the follow-up email that you'll get tomorrow, there'll be a link to the Google form to fill out, and then CPDU credit will get emailed to you. And actually, Denise is in charge of our CPDU credit, so we can thank her for having that available to us.
Thank you, Denise.
And what's that?
That's George.
Oh.
Just saying thank you for organizing all that. It's a huge amount of work.
We really appreciate it. But people have given us a lot of feedback that that's really nice to have too. So it's been nice. If you are not yet an ICTM member, we encourage you to go to ICTM.org and find out about how you can join us, because members are really the way that we're able to bring these webinars to you. So we would love to have you join us. And then also, just as a final reminder about NCTM Regional, it is in place of our ICTM conference this year. So we are the state affiliate that's co-hosting it or supporting it. So we would really like to see everybody join us. It's a big deal to have it come to us, and we're very excited about it, and it'll be nice to be able to connect in person and learn more and extend our learning. So anyway, thank you everybody, and hope to see you at our next webinar. Thank you.